What I want to share with you is a case study in Copiapó Valley. I will give you a sense of where it is in Chile. And what we asked ourselves is, we have a fairly sophisticated groundwater regulation that took some time to get there, but the evidence shows that it's ineffective. So what I want to explore with you this morning in our time schedule is a few hypotheses of why this may have happened. So very quickly, our groundwater regulation has a historical evolution. Our regulation in water in Chile is basically surface water. So in the first phase, 1960 to about 1990, groundwater significantly developed as water scarcity increased without the solid groundwater regulation to help that development would be sustainable. From 1990 to 2000, we began to evidence significant overexploitation, and therefore the sustainability of our groundwater use was being severely and correctly questioned. From 2000 on, based on this evidence, government developed an increasingly sophisticated groundwater regulation. Now, what is the situation with our groundwater regulation? Our water code has only few references to groundwater. Once again, the focus is or has been on surface water. This absence has been covered by guidelines and resolutions emitted by the DGA, our General Directorate of Water, which is our main water agency. And therefore, we continued with groundwater development in an institutional setting that put very few limits on groundwater use. In the 2018 Water Code reform, this was taken into account, and we introduced a stronger state intervention possibility to limit the exercise of users' water rights to extract groundwater. And one of them is to limit withdrawals, where by definition, the state says you can now only extract 80% of your water right, and restriction and prohibition. A restriction area is a groundwater aquifer that is giving us the evidence that it seems to be over-extracted and the sustainability is not as short. Therefore, with a restriction, we close the aquifer, but we can offer provisional water rights that will help us to continue studying the groundwater. Once the groundwater, the aquifer, clearly is depleting, then the DGA establishes a prohibition zone. No more water rights, and they begin to impose limits on the resource extraction. So let's look at the case study in this context. This is our country, 4,500 kilometers long, on an average of 200 kilometers width, going from an average of 4,000 meters altitude to ground level in those 280 kilometers. Therefore, our basins are very short and very rapid surface water flowing. I will look at this area, the Atacama region, and specifically the Copiapó aquifer. This area is the Atacama Desert, where in these areas, there is no register of rainfall in the past 300 years. So this is an extremely dry area. The Copiapó Valley is in the southernmost part of this Atacama Desert. And these images give you a flavor for what Copiapó Valley looks like. Desert. This is the Copiapó city, which, as you see, we always like green in our urban sector. So there's irrigation of urban sector. A strong mining. This is the second area of mining significance in the country, but also a significant growing agriculture. The importance of this agriculture in a fruit export country is that these are the first products to get to market. Therefore, they are the highest value. And that's why I'm willing to take the cost of doing agriculture in this area. So the aquifer, why is the aquifer so important? Our surface water flow in this valley is on average 1 cubic meter per second. So very little surface water. The aquifer is divided into 6 sections. This is a division administrative to simplify the DGA's management of the aquifer. This supposes, according to the water code, that these sectors are hydrologically independent. However, we do have horizontal movement, or had, given the depletion of the aquifer. This is a view, very quick, of our aquifer as we move towards the coast. These are the depth of our aquifer. We can reach up to 10,000 meters depth in the lower coastal area and about 400 meters depth in the higher Andes Mountains. So what has been happening? This shows you the evidence of over-extraction, where since the 2010, the rate of decrease in the aquifer levels is very significant. And this gives another idea. So what is the reality that maybe explains this? Recharge, 4,000 liters per second. How many water rights have been granted? 20,000. So clearly, this wasn't rocket science. This was going to happen. The withdrawals exceed the water recharge. And in the last 22 years, the estimates is that the aquifer has lost about 830 million cubic meters in this dry area. So this is a significant impact. So let's look at some of the hypotheses that can explain this. First, limited knowledge of the aquifer. This is common in many countries. Now, this limited knowledge explains in part why the DGA continued granting water rights in this situation. Now, there is a significant number of hydrogeological models. So why is the knowledge limited? They are contradictory models. So one model in the 2000s showed that the aquifer still had enough water to be granted water rights. However, there was another one that showed that it wasn't. And the issue here is the confidence that people, the state and users have on the models. We were lacking a co-modeling between users, the state, so that I believe the model, what it's saying. And therefore, I react to that model. What happened? This contradiction gave users the possibility to pressure the DGA to continue granting water rights. The DGA said, no, we do not have, but look at this model. So this led to this situation. The red line, the green bars show you when water rights were granted. The continuous line shows the liters per second that were granted. 1994, the first restriction, this is the first study that showed we were in trouble. The DGA declared a prohibition, therefore no more water rights should be granted. The question is, what began to happen here? If I'm not allowed to grant water rights, but they were still granted. What happened with these models in 2001? They lifted the prohibition and went to a restriction. Why? Pressures from the mining, from the agriculture, and the lack of water in the urban sector. The result, as I said, 20,000 liters per second that were granted. Another hypothesis, poorly defined water permits or water rights. We do have clearly defined water rights in our water code. But what happened with groundwater? The DGA used what we call the use factor. So farmers would come and ask for 100 liters per second. The DGA has to balance whether they have sufficient water for this or not. So, hypothetical situation, there's only 80 liters per second available. But agriculture does not irrigate in winter. Therefore, the effective use is 20%. Therefore, you're asking me for 100 liters per second, but that in reality is 20 liters per second. So we do have water. I grant the water right. What happens? That water right does not establish a limit on 20%. It gives you 100 liters per second. Therefore, the farmers can increase their extraction. What happened with this? Drinking was 75, mines 75. Today, the reality is drinking water and mines have 100% use. Agriculture went up to 40% because of efficiency and rebound effect. They increased the surface with more efficiency. So what happened? From the theoretical cubic meter volume, for example, in agriculture, 8,000 cubic meters per year, due to efficiency, they're up to 13,000 cubic meters. It's the same water right, but the intensity on volume has increased. The market has also led to some of this impact, but the major buyers and sellers of water rights are agriculture. There's very little water rights going from agriculture to mining sector. Therefore, it's in the agricultural sector. And to give you a flavor of our water markets here, a liter per second today, an effective liter per second, because we have dry water rights, goes for about $70,000. So it's a highly valuable resource. Our next hypothesis, compliance and enforcement problems. The Water Code, 1980, neoliberal framework, very low state powers. Therefore, water rights enforcement was basically at the users. The evidence showed that this was not really effective. Therefore, the new Water Code 2018 reform gave the state a larger influence and authority to be able to fiscalize and monitor water extraction. However, as in most of our countries, we pass a law that gives the state authority more responsibility, but with zero budget. So the agency that was already unable to do all of the things they were supposed to, now I have more. So the real effective monitoring was very low. Another hypothesis, inconsistency between management of surface water and groundwater and policy. We have an incentive for technology adoption, looking at the restrictions of cost and that factor on adoption decisions. However, our law that incentivizes technology adoption, its first objective is to increase surface, not water conservation. So we have increased our irrigation surface at a higher efficiency, therefore recharge has decreased. So inconsistent policies that are in place. The emergence of collective management. Theoretically, we should collectively manage groundwater user associations. However, we have to recognize that different from surface water, where there is a need for collective management. I need the infrastructure. We have to share the cost of that infrastructure. In groundwater, I have my well. I do not need collective management. That's the view. Therefore, these groundwater user associations were imposed. They exist, but for example, in the Copiapó River, 2000, the year 2000, the first groundwater user association was installed, and it was not collectively managed in an effective way until 2010. because I don't see why I need it. So at present, we have 4 new groundwater user associations. And the interesting thing with these is that they are working with their users to establish self-imposed extraction limits. We can design a limit on our exercise of our rights that is beneficial to us rather than the state's imposition. So this gives you a flavor that collective management is now becoming effective. Some concluding remarks then. The existence of water legislation is necessary, but not sufficient. We can have a very sophisticated water regulation, but we have to be careful to exercise it properly and limit some of the hypotheses that I said. In our water management scheme, the overallocation was inevitable. The state has to consider this in their implementation of the water regulation. And we need a crisis management mechanism. We have a crisis with water scarcity. We have to have a mechanism to take that into account. Therefore, the assumption that state and groundwater user associations will, because of the regulation, effectively manage is not absolutely correct. Thank you.
Thank you. So we have room for questions. If you want to rise, and then there, and then there. Okay, Ariel, yeah. Then Johannes, and then Sylvester.
Which one?
Ariel.
You woke up early.
Thank you, Guillermo. This is a fascinating and eye-opening and clearing presentation. I have a request if you can explain again the way that your water rights system is managed. You mentioned that water right is measured by liters per second. And it is well known in Chile that you have on the main roads, on the billboards, you have today, the flow in that segment of the river is X liters per second. So if water rights change by day or by week, how do you go to the user and tell the user, this is what you can do?
That's a very good question. Effectively, our surface and groundwater is defined in liters per second. I will take the surface water in Ariel's question. Surface water rights, that liter per second is defined, and the user knows this, for an 85% probability of effective. So the farmer, the user knows that on average, theoretical average, 1 out of every 5 years, I will not have enough water. So how do they manage it? A water sharing system, which is automatic. So the Surface Water Association calculates the water flow and defines, therefore, that Ariel, everyone, will receive 80% of their water. This is what we call in Chile alíquota. However, that does not happen in groundwater. It's not associated with your water. Yes.
Yeah, Guillermo, thanks for the presentation. Great presentation. I would like to have a bit more information on the modeling. You said there's an inconsistency in modeling. Was it assumptions? Was it the algorithm or data?
It was significantly more important, the data, but there's also assumptions. And just to give you a button of why users sometimes do not believe the models, the last model that was developed by the DGA, we have a desal plant there now. However, the model, looking at it, has the desal in the middle of the valley. So, this is a useless model. It's mainly data, but it's also assumptions and looking at the model.
Good morning, and thanks for a very interesting presentation. My question is with regards to water pollution. And when I look at your topic, water for mining and agriculture, if you present this to local stakeholders, they are going to scratch their head because we have got serious problems in this country. Agriculture versus mining. And we know that mining companies are polluting the environment, and farmers are losing high production because of that, especially farmers that are farming in the downstream. They are in serious trouble, especially in the low field, that the Mpumalanga region east of the country. How are you solving the water pollution issue? Is there any strategies that maybe we can adopt from Chile and also use it here locally? If you can just share them, maybe with us, or maybe we can engage during tea break. Yeah.
As mining developed, there was evidence of increasing water pollution. And contrary to our water regulation, we do have a very strong and effective environmental regulation. So there is strong monitoring, and the projects all have an environmental impact assessment study. And the result of this establishes requirements that the mining companies have to satisfy. It's not 100%. There's still some pollution, but it's less than what we would have evidenced without this strong regulation.
Yes, very good presentation. I enjoyed it very much. All along, I had the idea that Chile is a real model for, water markets, water rights, and all that. So I get a bit of feeling that you have also some of the problems which so many other countries are having. Am I right?
Yes. The regulation on the paper has been studied, and it seems to be a very good model. The problem is in its implementation. Now, water markets have been effective. We have active water markets. And so there is significant reallocation in different phases. So the market aspect has been effective. However, we do not have very effective market regulation. So even though we have significant transactions, there are some issues associated with it. So yes, I look at it. It is an interesting model, but you have to learn from the experience of how we implement it. So it's not an issue, in my opinion, of modifying the regulation. The issue is, let's do what the regulation really says we can.
Yeah, thank you for your presentation. I really enjoyed it. I'd like to just get you to comment a bit more, follow on from that last point you made. So one thing I'm especially worrying about in Australia, so we have a lot of regulations. We have a lot of investment in state departments to actually check are users doing the right thing. New South Wales, for example, is leading the way with, eyes in the sky using satellite technology and boots on the ground. But then there can be still a disjoint between, even when you detect users doing the wrong thing, what sort of legislation goes through in terms of, are they fined, are they prosecuted, are fines enforced, etc. Can you please talk about the Chile situation?
In terms of, I will differentiate surface water from groundwater. As I mentioned, more authority to the state and the Water User Association was implemented in 2018. We do not have effective monitoring, as you just gave us an example in Australia. We are moving towards that. However, the effective monitoring and sanctions is at the Water User Associations and surface water. They have personnel who do a route throughout their area of influence. They measure water flow, they write it, and whoever is not complying receives a fine. If I detect it again, the fine is higher. And in the third non-compliance, water is cut. Now, if the user in Surface Water Association does not pay the fines, then the user association takes the water right and auctions it. So in surface water, we have strong incentives. In groundwater, very young groundwater user associations, that has not been the case. And that's where government has come in. Now, if I look at the fine and the probability of being monitored, the non-compliance cost is very low. The compliance cost is extremely high. So there aren't real incentives to comply. And that is an issue we have talked with. Difficult to have more budget, to have better monitoring. Let's increase the fine so non-compliance costs increase. But that's a major issue. That's a good point.